All right, hello, good morning. Today we're going to start chapter 5. We're going to start with 5.1, which is kind of an introduction section. And chapter 5 is dealing with probability. So it's going to feel a little bit more mathy, this chapter. The whole point is we have to learn how to find probabilities because it's going to come back up again when we do our experiments where we get our results, and we're going to try to see if our results are something other than what could just happen by chance. And so we have to figure out the whole idea of chance. So on this first page, we kind of have some definitions. The key idea up here at the top is that chance behavior is unpredictable in the short run, but has regular and predictable pattern in the long run. So the idea behind that would be if we flipped a coin, let's say 4 times only, it could happen that you get all 4 heads. Well, we know that the probability of getting a head should be 1/2, but if I got 4 heads in 4 flips, that's not a probability of 1/2. That happened 100% of the time, not 50% of the time. Or what if I flip the coin 4 times and I get 3 heads and 1 tail? Again, that's not demonstrating a probability of 1/2. But if I flip the coin 10 times, 20 times, 100 times, 500 times, then it's going to start to get more toward the 1/2. I'll have a proportion of heads that's closer to 1/2. That also goes along with this law of large numbers. As the number of repetitions of a chance process increases, the proportion of times a specific outcome occurs approaches a single value. That's what I was saying before about, if I flip a coin 500 times, the proportion of heads should approach a single value of 1/2. The probability is a number between 0 and 1 that describes the proportion of times the outcome would occur in a very long series of repetitions. That's key. So if you're ever told to interpret the probability, make sure you say something about, if we were to do this many, many times, then the proportion would be close to such and such. But it's that idea that you're doing it over and over and over and over. Here's just a picture that helps kind of visualize flipping a coin. And this is flipping the coin only 20 times. It's the proportion of heads. So when you're only flipping it less than 10 times, you could have way more heads than tails, or you could have way less heads than tails. But as you keep flipping the coin, up to 20 times, now your proportion of heads is going to be about 1/2. If you look at all of your numbers, count them all up, you're going to have about 1/2 the number of heads and 1/2 the number of tails. Now, if we project that out farther to 500 tosses, you see how it gets more and more closer and closer to 0.5. That proportion. So if we toss the coin 500 times, counted all the heads and all the tails, we would have about 1/2 and 1/2. That's that long run relative frequency. It's over many, many, many trials. Okay, so here's a scenario. Athletes are often tested for use of performance-enhancing drugs. Drug tests aren't perfect. They sometimes say that an athlete took a banned substance when that isn't the case. So it will falsely accuse them of taking the drug. That's a false positive. They tested positive for the drug, but it's false. It says they took the drug when they really didn't. Other times, the test concludes that an athlete is clean when he or she actually did take a banned substance. That would be a false negative. The test says, nope, they didn't take drugs, but it's false. They really did. For one commonly used drug test, the probability of a false negative is 0.03. That's for a false negative. Interpret this probability as a long-run relative frequency. Okay, so we have to write a little sentence or two about what that probability means. So again, it's a false negative. So that's when they actually took a banned substance but the test concludes that the athlete is clean. Okay, so let's try to put this in words. Okay. I would say something like, if we test many, many athletes, and not just many athletes, it's the athletes who have actually taken the banned substance. Because that's what a false negative is referring to, people who have taken the banned substance. Okay, so if we test many, many athletes who have taken a banned substance, about how many of them? 0.03, or we could say 3%. About 3% of the time, the test will say that they are clean or that they have not taken it. That they okay, something like that. So if we test many, many athletes who have taken a banned substance, about 3% of the time the test will say they have not and that they are clean. So I hope you recognize that it's not just testing many, many athletes, it's specifically testing the athletes who have taken the banned substance. Okay. All right, which is a more serious error in this case, a false positive or a false negative? Okay, so a false positive, looking back up here, a false positive is when they say an athlete took the substance, but they didn't. So think about that. If you're being accused of taking steroids, but you really haven't, what would be those repercussions? Well, you would probably make newspaper headlines or magazine articles or something like that, making you seem like an awful person when you haven't done it at all. That would be a false positive. A false negative would be, hey, I took all these steroids and nobody caught me. So you could kind of make an argument, probably for either one. But I gotta go, I think I'm gonna go with the false positive as being worse. Because when people say bad things about you, it's really hard to come back from that. You know, even people who have been jailed and then later proven innocent, they still, it's hard for them to get jobs and it's hard for people to trust them, even though they didn't do anything wrong. It's just this like social stigma or something. So that's what I'm going to say. I'm going to say a false positive is worse. Because the name of a clean athlete might be unfairly whatever you want to say. That's definitely not the only way to say that. Now, every scenario is different. So, you know, like if we were talking about like jail, murder, or something like that, is it worse to be put in jail for something you didn't do? Or is it worse that someone who did commit the crime got away scot-free? So sometimes both are really bad. Okay, next thing. All right, a TV weather person says that since we have had mild winters the past few years, we're due for a colder winter because of the law of averages. If we assume weather is a random event, is this statement correct? So we've had a whole bunch of mild winters, we're due for a colder winter because of law of averages. I think that weather person is maybe trying to use the law of large numbers that we had on the first page. But they're using it incorrectly because law of large numbers, you'd have to look at a long period of time, several years. And this person is only talking about the past few years. So number one, they're applying that law of large numbers to a small number of years. That doesn't work. But then also, you know, like let's say you're in California and you've had mild winters the past few years. You're not due for a colder winter. In California, maybe all the winters are mild. Or in Minnesota, you know, it could just depend on like the area that you're in, the region that you're in. It might not be independent from year to year. Like Antarctica is going to have terrible winters every winter. They're not going to be due for a mild winter. So anyway, that TV weather person is not making a correct statement. Okay, the next thing we're going to talk about is how to do a simulation. And with simulations, you can do them lots of different ways, but one way we can do it is with a random number table. And I'm going to show you an example of that. But here's the thing in yellow is important. When you're using the table of random digits to simulate probability, repeats are allowed. Okay, because these numbers are going to represent a success or fail. So like, let's say flipping a head is a success and flipping a tail is a fail. So I could get heads several times or tails several times. I'm not going to skip a repeat head or a repeat tail. It's not people we're picking or subjects we're picking anymore. It's whether we got what we wanted or we didn't. So repeats are allowed. I hope you make a note of that. Okay. All right, we're going to do this example here. Actually, I'm going to have to stop the video for a second, and then I'm going to start it up on a separate video because I only have a certain amount of time I can do for each video. So I'm going to stop this video and then go to part 2 to finish this example.